Okay, so let's look at solving systems of equations in 3 variables today. I'm going to try to do my best to use different colors and make as much sense of this as I can, because it's really all about just keeping things organized. It's a very tedious process, as you'll see. It's not hard, it's just tedious, and you have to stay organized. So if you don't normally stay organized on your homework, tonight would be the day to do that, okay? That would be the best time, because if you make one mistake, one negative sign is going to throw this whole process off. All right, not to scare you, just to warn you, okay? So let's name these equations. I've got equation 1, equation 2, and equation 3. I'm going to look at this and I'm going to say, all right, I've got to come up with a plan to eliminate one of these variables, because I don't know how to solve an equation or a system with 3 variables, but I do know how to solve a system with 2, right? That's what we did last night. So let's get rid of something. Let's get rid of m. Yeah, let's get rid of m right here. I immediately look for inverses. I see that these could be inverses of each other if I applied a negative sign to this whole equation here. So I'm going to make myself a little note right here that I'm going to write down equation number 2 is m minus n plus p equals 3. And equation number 3, I'm going to apply that negative. Negative m minus 4n plus 5p equals 0. Now, if that's difficult for you to do and you make mistakes easily, I suggest you use parentheses and distribute that out. Because all I had to do right now is make this negative 5p, and I would now take a 5 or 10 minute problem, and the whole thing's going to be wrong. Okay? So I would be careful. Let me just undo my little arrows there. All right, so now that I have these are inverses of each other, I'm going to go ahead and add them together. And I have negative n and negative 4n is negative 5n plus 6p equals 3. There's one. I need another one, though. And I can't just use one of these. I have to create another system of equations with only 2 variables. I used 2 and 3. So now my only options are 1 and 2 or 1 and 3. So which one you want to use? 1 and 2? Okay. So let's do equation 1 is 3m minus 2n plus 4p equals 15. And equation 2. How do we want to manipulate equation 2? If you multiply it by 2 or negative 2, you're going to eliminate n. Well, we want to eliminate, but you could do that. See, now that's what makes these a little bit rough. You've got to think to yourself, yeah, I can jump there and start eliminating, but we're trying to eliminate n's the first time around. Hold on. So I'm going to multiply by negative 3. I get negative 3m. I'm going to be really careful right now. Then I get positive 3n and negative 3p, which gives me also, I would be really careful here too, negative 9. So I know that my m's cancel out, and then I'm left with 3n and negative 2n is just n plus p equals 6. Now I'm ready. Okay, so now I'm going to do my best. I think I should change color now, because now we're talking about a different system, correct? I've got to take this one and combine it with this one. So I'm going to take negative 5n plus 6p equals 3. And over here I have n plus p. Which one do you want to eliminate, my n's or my p's? Go n? Okay, so I need to multiply. I could do substitution. Or I could multiply everything by 5, right? So you guys want to use substitution? Okay, that would be a good practice, right, for tomorrow's quiz? See, I never even think about that. So n equals negative p plus 6, right? So now I can substitute n into this equation right here. N equals this, so n is going to go right there. See that? So negative 5n plus 6p equals 3. N equals negative p plus 6. Distribute, and I get positive 5p minus 30 plus 6p equals 3. 11p minus 30 equals 3. I don't want to lose everything here, but I do want to make this neater. Here we go. Everybody good so far? Now add 30 to both sides, and I get 11p equals 33, so p equals 3. There's 1. That's 1. You see what I'm saying? But it starts to it unravels very quickly at this point, right? Because since I have p, can't I just substitute p in right here with this equation here? So I have n equals negative p plus 6, p equals 3, so n equals 3, right? And now go back to the whole thing. Hold on. Number 2, let everybody process it, unless I made a mistake. Just let everybody process and we'll ask questions at the end. Number 2 is m. Do I know what m is? No. I can use any one of these. I'm just using number 2. I wrote it right there. Number 2. M minus n, which is 3, plus p, which is also 3, equals 3. Negative 3 and positive 3 cancel each other out, so m equals 3. And just by absolute coincidence, they all equal 3. Finally, you have to put them in order, even though it sounds silly because they're all 3, 3, 3. But you have to put them in order. What would be the order? M, N, P. Exactly. So 3, 3, 3. Any questions? What do you guys think? It's tedious, right? But that's one problem. Okay, so maybe we could do a less complaining and be a little bit more.
I wasn't complaining. I was just asking.
Yes, you do.
Okay.
Okay. Use elimination to make a system of 2 equations. All right? So you want to eliminate, you want to concentrate on one variable. You want to do something, manipulate one of these equations and the other one to eliminate one variable. Then you want to pick 2 more and eliminate another variable of the same type, right? You want to pick something. I'm either going to get rid of all the m's, or I'm going to get rid of all the n's, or I'm going to get rid of all the p's, because I just want 2 variables. 2 variables is enough to work with, right? Yes.
You're checking your answers by counting. How do you know that P was also 3?
Because P was the first one I found. Okay? Yes. And putting little boxes around it like this helps too, keep yourself organized. Evan. What?
When you plug P back into the N equation,
Yes.
will it be the same thing for the
This one?
elimination?
Yes. If you were to use elimination for this instead, yes, it would be the same value. Good question. If you plugged in P into the top equation, you would now have two unknowns. Right? That's why you kind of have to whittle it away until you find one, and then go back to one that you have only two variables in it, then whittle that away. Then at the very end, don't go back up to the front until you have two of them and you just need one more. You're just going to confuse yourself. You just keep going kind of, you know, it's kind of linear. You just keep going down, 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 down. Stay down here until you can't do any more. Then once you've got two solutions, go back up to the front and put them both in and find the third one. Okay? So that's what it says. Use elimination to make a system of two equations. Ignore the top three and just work within the two. Then solve the two-system equation. Then solve for the third variable by substituting everything back in. Any more questions? All right, so this one's going to go a little bit quicker, so I'm going to go a little bit faster. Then I'll give you a chance to write it down, and then I'll unveil this one, and you guys can do one on your own. Okay, so I'm going to label them. This one's number 1, this one's number 2, this one's number 3. Immediately I see I've got opposites here and opposites here. So this one's going to go pretty quickly. So I'm going to take equation 1 and equation 2 and just add them together. 2x minus y plus 2z equals 15. Negative x plus y plus z equals 3. Those go together, and I have x plus 3z equals 18. I need to fix that. So that could have caused me a problem right there, right from the get-go. All right, then I'm going to take second equation and third equation and do exactly the same thing. Negative x plus y plus z equals 3, 3x minus y plus 2z equals 18. These go away. I'm left with 2x plus 3z equals 21. Got my two equations. Starting a new system. Let's put, these are going to go away. So we'll just start with this first one. X plus 3z equals 18. Apply a negative to this one and make it negative 2x minus 3z equals negative 21. These go away. Now that you've seen it the second time, it's not as hard, right? It becomes negative x equals negative 3. So x equals positive 3. Nope, they're not all going to be 3. There's 1. I'm saying I should put this one back right there. So let's do that. I get x, which is 3, plus 3z equals 18. Subtract 3 from both sides, and I get 3z equals 15. So z equals 5. There's my second one. I'm almost there. Go back to my third one. I'm going to make it blue again. Which one you want? 2. So number 2 says negative x, which is negative 3, minus, looking at number 2, plus y plus z, which is 5, equals 3. Negative 3 and positive 5 makes 2. Y plus 2 equals 3. Subtract 2 from both sides, y equals 1. There's all 3. X is 3, y is 1, 5 is z. Does it matter what order they're in? Yes, absolutely. Questions? Can you see that these things can be done different ways?
Yeah.
So don't, because they can be done so many different ways, that's why it's so important that you keep yourself organized, because you can start mixing yourself up in your head, right? So label them, make sure you stay nice and neat and orderly, take up as much room as you need to. Okay, so I'm going to go ahead and pause it now and let you guys copy this down. And for those of you that have it copied, go ahead and start on this problem here. Okay, so now that you've got this, let's take this one, pick this one up, cut it, and paste it on the new page. All right, so are you ready to get upset with me? Now look at it. Okay. Evan. That is kind of rough. It's abstract, right? You're used to seeing, I just showed you stuff with 3, and now there's 2 in some and 2 in the other. And all right, can you see, guys, that's enough. So this is equation 1, this is equation 2, and the one that's covered up is equation 3. If I put equation 1 and 2 together, I get a plus b equals 3. Then I have negative b plus c equals 3. Add those together and the b's cancel themselves, and I end up with a plus c equals 3. 6. I could have just totally messed up the whole thing. Thank you. Okay, gosh, guys. Glad you guys don't have anything to throw at me. All right. So, you wouldn't do that to me. Now I can take 3 straight away from here, and I now have myself a system of 2 equations, right? With 2 variables. So I've got a plus c equals 6, and if I apply a negative to this one, I have negative a minus 2c equals negative 10. I should have been using different colors here. My a's go away, and I'm left with 2c, negative 2c plus c is negative c equals negative 4, so c equals 4. There's my first one. Now that I know that, what can I use? Don't go back up here. Don't go look in here. What can I use? I can use that right there. So a plus, now we know what c is, 4 equals 6. What plus 4 equals 6? 2. Now, what do I need? I need b. So I couldn't use number 3, because I could use 1 or I could use 2. So let's use equation number 1. Equation number 1 says a, which is 2, plus b equals 3. So what does b have to be? 1. Right? b equals 1. So my solution is 2, 1, 4. Questions? All right, at this point you've got 20 minutes to do homework, but let's look at this really quick. Check this out. Equation number 1, equation number 2, equation number 3. What would you eliminate? The G's?
The 1 and 3.
Right?
Yeah.
So what?
Is that the one that's on our quiz?
That was funny. That is what, remember the planes that we saw in the very beginning? Those would be like parallel planes, right? Yeah, this is no solution. What about, I think this one. Check this one out. Guys? Let's see. I think it's this one. Check this one out. You don't have to write it down. I'm going to give you a chance right now to start doing some work. Okay. So what would you eliminate? 1 and 3, why? Yep. 1 and 3? Okay, let's look at 1 and 3. 4x plus 4y minus 2z equals 8. If I apply a negative, I get negative 4x minus 4y.
Negative 2.
Oh, thank you. That makes more sense. I just started doing it automatically, right? And then positive 2z equals what? Equals negative 8. It's infinitely many. Good job. Right? Isn't this 0 equals 0? All of them cancel out, right? Do they all cancel out? So I have nothing on this side and nothing on this side. So this is infinite. Infinite solution. All right, let's talk about what we did. What did we learn today? A lot. We didn't really learn that much.
Solving system of equations with 3 variables.
We basically learned how to isolate a variable and then do exactly what we did yesterday. Right? Okay, on your assignment sheet, I want you to write the process of solving systems with 3 variables in your own words. Write out that process. That is your closing thought today. I can. It was basically just 4 equals 4 is what type of solution, 4 equals 2 is what type of solution. All right, great job, guys.